Change one number by a fraction. The universe doesn't exist, you don't exist, nothing does. 6 numbers control whether there are stars, planets, or atoms. Physicists, atheists included, agree. These numbers are set with a precision that defies comprehension, and no one can explain why. Here's what fine-tuning means. The universe runs on a handful of fundamental constants: the strength of gravity, the charge of an electron, the energy of empty space. These aren't chosen by any theory. They're just what they are. But if any of them were slightly different, not dramatically different, slightly different, the universe couldn't support life. In many cases, it couldn't support matter at all. The astronomer Royal Martin Rees identified 6 of these numbers, 6 dimensionless constants that together determine the structure of everything: the ratio of electromagnetism to gravity, the efficiency of nuclear fusion, the density of the universe, the energy of empty space, the size of cosmic ripples, and the number of spatial dimensions. Rees put it simply: if any one of them were untuned, there would be no stars and no life. Start with gravity. It's the weakest force in nature, 10 to the power of 36 times weaker than electromagnetism. But that weakness is precisely what allows stars to burn slowly enough for planets to form, for chemistry to happen, for life to evolve over billions of years. Make gravity slightly stronger, and stars burn through their fuel in millions of years instead of billions. Make it weaker, and matter never clumps into stars at all. The precision required. 1 part in 10 to the power of 40, at minimum. Now the strong nuclear force, the force that holds atomic nuclei together. Change it by 2%, just 2%, and the universe is sterile. 2% stronger and all hydrogen fuses into helium in the first moments after the Big Bang. No hydrogen means no water, no stars powered by hydrogen fusion, no chemistry of life, 2% weaker and protons can't stick together, no elements beyond hydrogen, no carbon, no oxygen, no you. This brings us to one of the most remarkable stories in the history of science. In 1953, the astronomer Fred Hoyle was trying to figure out how stars produce carbon. He realized that carbon could only form inside stars if a very specific energy resonance existed in the carbon-12 nucleus, at exactly 7.65 mega-electron-volts. No one had ever observed this resonance. Hoyle predicted it had to exist not from nuclear physics, but from the simple fact that carbon exists. Physicists went looking. They found it, at exactly the energy Hoyle predicted. A shift of just 0.5% in that resonance would make carbon production in stars essentially impossible. No carbon, no life. Hoyle was shaken. He'd started as a committed atheist. He later wrote, "A common-sense interpretation of the facts suggests that a superintellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. That's not a preacher. That's a Cambridge astrophysicist staring at his own data." But the most extreme fine-tuning in all of physics belongs to the cosmological constant, the energy of empty space. Quantum field theory predicts that the vacuum should seethe with energy, an enormous amount of it, but the actual observed value is 120 orders of magnitude smaller than what the theory predicts. That's 10 to the power of 120 times too small. Physicists call it the worst prediction in the history of science. Nobel laureate Steven Weinberg showed that if the cosmological constant were even slightly larger, the universe would have expanded too fast for gravity to pull matter into galaxies. No galaxies, no stars, no planets. Paul Davies put it this way: the life of the universe is balanced on a knife edge. No knife in the universe could have an edge that fine. One more, the density parameter, omega. At 1 second after the Big Bang, the density of the universe had to be tuned to 1 part in 10 to the power of 60. Not 10 to the 6th, 10 to the 60th. If it were slightly higher, the universe would have collapsed back on itself before the first star could form. Slightly lower, and matter would have dispersed too fast for anything to clump together. Ever. But all of this pales next to a calculation by the Nobel Prize-winning physicist Roger Penrose. Penrose asked a different question: what is the probability that the universe began in the extraordinarily ordered low-entropy state required for everything we observe? He applied the Bekenstein-Hawking entropy formula to the initial conditions of the Big Bang. The answer, 1 in 10 to the power of 10 to the power of 123. That number is so large it cannot be written out. If you wrote one digit on every atom in the observable universe, you would not have enough atoms. It is, by many orders of magnitude, the most precisely tuned quantity in all of physics. Penrose himself wrote, "In order to produce a universe resembling the one in which we live, the Creator would have to aim for an absurdly tiny volume of the phase space of possible universes." And there's a deeper issue. In 2003, physicists Arvind Borde, Alan Guth and Alexander Vilenkin proved a theorem that sent shockwaves through cosmology. The BGV theorem shows that any universe with an average positive expansion rate, which includes our universe and every inflationary model, must have had a beginning, not just our observable patch. The whole thing, even the multiverse if it exists, had a starting point. Vilenkin, one of the theorem's authors, wrote, "Cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. Something caused the universe to begin, and whatever that something is, it existed outside of space, time, and matter." So physicists are left with three possible explanations. 1, it's a coincidence, astronomically unlikely but we got lucky. 2, there are infinitely many universes with different constants and we happen to be in one that works. 3, the constants were set intentionally. Each of these has serious problems, and none of them is settled science. The multiverse is the most popular naturalistic response. The idea is elegant. If there are infinitely many universes, each with randomly set constants, then of course some fraction will permit life. We're in one of those. Problem solved. But is it? The cosmologist George Ellis, who co-wrote the foundational textbook on general relativity with Stephen Hawking, calls the multiverse untestable. He wrote in Nature, "If the multiverse cannot be observed, it is not science." And the multiverse has its own fine-tuning problem. The mechanism that generates all these universes, eternal inflation, string landscape, whatever it is, must itself have the right properties to produce universes at all. You haven't eliminated fine-tuning, you've pushed it back a level. Then there's the anthropic principle. The argument goes we can only observe a universe that permits observers. So of course we find ourselves in a fine-tuned universe. We couldn't be in any other kind. It's logically valid. But is it an explanation? The philosopher John Leslie offered a thought experiment. Imagine you're facing a firing squad. 50 trained marksmen. They all fire, they all miss, you're alive. The anthropic response would be, well, you'd have to be alive to notice it. True. But deeply unsatisfying. The fact that you survived still demands an explanation. Either the marksmen missed on purpose or there were millions of executions happening simultaneously, and you're in the rare one where everyone missed. Chance, multiverse, or design, the same three options. There are other responses. Some physicists argue that a future theory of everything will show that the constants are not independent, that they're determined by deeper physics we haven't discovered yet. That's possible. But even then, the deeper theory itself would need to be fine-tuned. Others propose Lee Smolin's cosmological natural selection. Universes reproduce through black holes, with slightly mutated constants each time, and natural selection favors constants that produce more black holes. It's creative, it's testable in principle, but it predicts constants optimized for black hole production, not for life. The overlap between the two is not perfect. Freeman Dyson, one of the greatest physicists of the 20th century, put it this way: "The more I examine the universe and the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming." Dyson wasn't a conventional believer, but he wasn't willing to dismiss what the numbers were telling him. Here's the honest position: fine-tuning is real. It's not controversial among physicists. The precision of these constants is a fact. What's controversial is what it means. Does it point to a designer, to a multiverse, to deeper physics, or to something we haven't even imagined yet? The question is genuinely open, and it might be the most important question in science, because if the universe was designed, that changes everything. And if it wasn't, if all of this is just an accident, that changes everything too. The universe is fine-tuned for the existence of matter, stars, and chemistry. But fine-tuning for chemistry is not the same as fine-tuning for life. For life, you need something more. You need the right conditions on the right planet in the right solar system at the right time, and you need something that physics alone cannot explain: consciousness, minds that can ask why. That is episode 2.